Hello all, welcome to TechGen. Today I'm here to share about collision domain and broadcast domain. Let's go into the topic. Collision domain, when two devices are connected in the shared network or same local area connection and they are trying to send the data or packet or frame at the same time, then collision can happen. Okay. Once collision happens, again they need to send the data again and again. Because of this, it reduces the network efficiency. Let's see in the diagram. Here we have a hub which connects the different devices together for the communication, and all these devices are belongs to same network, and they are in case if this computer and this computer is trying to send the data to this computer and both send it to the hub. Hub receives the data or frame from both the devices and collision can happen. Okay. Because of this, again they send the frames or data again and again. This is called the collision. Okay. And let's see the broadcast domain. It means it's actually a logical division of the computer network, and we can also call it as a portion of a network. When a broadcast traffic sends out from a device, all other devices on the broadcast domain receives the broadcast traffic, and they should pay the attention about the broadcast traffic. Okay. Here we can take it as switch. Each port on the switch belongs to separate broadcast domain and separate collision domain. So suppose if this computer try to send the broadcast message to other devices on the network, means first it should reach out to switch, then what switch do? It broadcasts to all other devices connected to the switch on the ports apart from the port that received the broadcast message. So it will not send it to this port, it will send it to all other ports. Okay. This is called a broadcast, and each VLAN belongs to a different broadcast domain, and we can discuss about VLANs in the upcoming session. Then we can see the difference between the broadcast domain as well as collision domain. And if you see, hubs and repeaters are belongs to layer 1, and these are the old technology devices, and nowadays we are not using hubs and repeaters. We are using only switches and routers, and this hubs and repeaters are belongs to physical layer, and switch belongs to data link layer, and we can also see nowadays as layer 3 switches, and router obviously it belongs to network layer. The function of a hub and repeater: hub, what it do, whatever signal it receives from the device, it just send out from all other ports. So it receives the signal, it pass it to other devices which are connected to the hub. If it is a unicast, it do unicast. If it is a multicast message, it do multicast. If it is broadcast, it do broadcast. Okay. And repeaters, normally it is used to connect, to extend the signal. It just to extend the signal, we can use the repeaters. Hubs can become the repeaters, but repeaters are not become the hub. Repeaters are not used to connect a lot of devices together for the communication. It just extend the signal. Okay. And switch, what it do, it keep a track of uh, the devices, which device connected to which port. So it has a MAC table. According to the MAC table, we can find out to which port which device has been connected. Router, same same as a switch. Router connects two or more network segments, either LAN to WAN, WAN to LAN. Okay. The data transmission in hub it's in the form of signals or bits, zeros and ones, and in switches it's in the form of frames. In L2 switches and L3 switches we can also see it as packets. Normally in routers we can see it is in packet format. And transmission type, what it do, whatever information or signal it receives, it just flood out over all other ports. And if it receives a unicast, it send it to unicast. If it is a multicast, it send out to few more devices, and if it is a broadcast, it send out to all other ports, all the ports. And switch, first it do what it do, because the MAC table should be empty at the initial connection of the devices. So first it broadcasts, then depends upon the message, either it unicast or multicast. Same thing router can do. Initially it broadcast and later it do unicast or multicast based upon the requirement. And device type, hub is not an intelligent device because it don't have any software inside it. It just send the signal out from the devices which are connected to the ports. So it won't alert any frames. But switch and routers are intelligent devices. It has a software and it can alert the frames. Okay. And in router it can alert the packets because it belongs to layer 3 network. And usually hubs and repeaters are used in LAN connection, and switches also belongs to LAN, and if it's a L3 switch it also belongs to WAN. And routers usually belongs to LAN, MAN, WAN. And possibility of the collision, high possibility in hub and no possibility because each port belongs to separate collision domain and separate broadcast domain. And in routers also there is no possibility. Okay. And hub don't have any software, so it won't store any information. So it won't store any information how the frame or data has been read on the hub. It reads by the MAC address. Even in switch it uses the MAC address, router uses the IP address. And what it store, hubs don't have any software to store the information. Switches have software, so it stores the information in the table format, a MAC table. And in router it uses the routing table. Broadcast domain, all the ports belong on the hub belongs to only one broadcast domain. And if it is a 20 port hub or 15 port hub or 5 port hub, everything belongs to the same only single broadcast domain. And switch, each port, switch and router are similar, each port belongs to a separate broadcast domain. And in switch, if it is a different VLANs, each VLAN belongs to separate broadcast domain. And collision domain, hub has a collision domain all over the ports, and Ethernet switch, it creates the collision domain on each port. Same, router also creates the collision domain on the each port. Compared to cost, hubs are cheaper than switches and switches are cheaper than routers, but it's costly than hubs. Nowadays switches also more costly. Let's see a scenario of collision domain and broadcast domain on this. And we have hub, switch and router are connected with all other PCs. And now we are going to find the collision domain. So as I told, in hub, switch and router, each and every port belongs to separate collision domain. And broadcast domain, hub only have single broadcast domain and switch have the how many ports. Suppose if it is a 10 port switch or router, each port belongs to separate broadcast domain. So it means it have 10 broadcast domains for switch and router. If it is a 20 port switch, it have 20 broadcast domain. If it is a 15 port router, it have 15 broadcast domains. Okay. For hub, If it is a 20 port hub or 30 port hub, it will be having only single broadcast domain. Okay. Yeah. Here we have 6 PCs are connected together with the hub, switch and router. So let's find the collision domain. Always router is greater than switch, switch is greater than hub according to the domains. Consider this logic and then it will be easier to identify the collisions and domains on the network. So number of ports on router and switch is equal to number of collision domains and broadcast domains. So this router have 3 ports which are connected to PC, and one is connected to switch and another one is PC. So here each port belongs to separate collision domain, 3 collisions, and the switch also have 4 devices are connected, but here already it's connected to the collision domain of router. So we can consider both are in same collision domain. Okay. And hub, we are not considering each part of the port on the hub because hub is already connected to switch. It's already in the collision domain. So how many devices are connected to the hub? All come to the same collision domain. Okay. So we have 1, 2, 3, 4, 5, 6. So 6 collision domain, and let's see the broadcast domains. On router, each port belongs to separate broadcast domain. Same for the switch. But here we have 3 ports belongs to a broadcast domain, but here when come to the switch is already connected to the router's broadcast domain, so it will consider as a 1. Okay, then we have 3 broadcast domains here. That's all. And here we have 2 routers and 5 switches and 9 PCs are connected. So now we are going to find how many collision domains and broadcast domains in this network. So let's consider, first we'll see the broadcast domain. So let's consider from the router side. This belongs to one broadcast domain and this entire thing belongs to one broadcast, and this entire thing belongs to one more broadcast. So total we have 3 broadcast domains in this network. Okay, and for collision domain total we have 15. Let's see how it's going to be 15. See, as I told you, there are 3 broadcast domains as per this diagram, and we can see 15 collision domains because each port belongs to the collision domain. So every port on the switch belongs to separate collision domain. Because why we consider the collision domain separately here? Because one switch to another switch, we have separate connection, so it belongs to another collision. I hope you got some idea about collision domain and broadcast domain. The same thing, number of collision domains and number of broadcast domains, 3 and 50. That's all. Thank you for watching. I hope you like this video. If you like it, please subscribe for my channel for upcoming videos. Thank you guys.